So in this video, we're going to graph exponential function. So to get a sense for the behavior of an exponential function, let's look into a function fx equals to 2 to the x. What does this function look like? Alright, so when x equals to 1, fx equals to 2. When x equals to 2, fx equals to 4. When x equals to 3, fx equals to 8. When x equals to 0, the function equals to 2 to the 0 power equals to 1. When x equals to negative 1, so 2 to the negative 1 is 1/2. When x equals to negative 2, it's 1/4. When x equals to negative 3, we have a 1/8. Now we're going to use some tool to look at what does the function look like. Now let's open a decimals.com. And we're going to use a table. When x equals to negative 3, y equals to 1/8, it's going to have a pawn. And when x equals to negative 2, negative 1, 0, 1, 2, 3, we have negative 1, positive 1/4, 1/2, 1, 2, 4, and 8. So if we connect all of these dots together, let's see what happens. Now we're going to connect all of these with a 9. Oops. So we want them connecting by 9. So this 9 is a curved 9, right? So similarly, if we if you pay attention to the graph, you might notice that this function is positive for all of the value x. Even though x is a negative number, you will still get a positive output. And then the second thing that you might notice is as x increases, the function goes faster and faster. And as x decreases, the function's value grows smaller and approaching to 0. And this is an example of an exponential growth function. So now let's try another function. If I have a function g of x equals to 1/2 to the x. Let's see. We make a table like what we did earlier. We're starting with negative 3, negative 2, negative 1, 0, 1, 2, 3. So when x equals to 0, 1/2 to the 0 power is 1. And then to the 1th power, we have a 1/2. To the 2nd power, we have 1/2 to the 2nd power is 1/4, and this is 1/8. And then to the negative 1, 1/2 to the negative 1 power is equal to what? 1 over 1/2, which is equals to 2. And then what about to the negative 2 power? Well, this is equal to, when it comes to negative, we know that this is going to be a reciprocal. So this is equals to 2 squared, which just gives you 4. And then to the negative 3 power, which gives you the 8. So now let's plot these points. So I am going to type in the points. And then when it equals 8, 4, oops, I'm sorry, 8, 4, 2, 1, 1/2, 1/4, and 1/8. So you will see these green lines is going to be represent our g of x function. Yeah. If I connect these points together for the blue line, this is representative g of x function. If you notice, this function also are positive no matter for all the value of x. But as x increases, the function grows lower and lower and is approaching to 0. But as x decreases to negative, the function grows faster and faster. In fact, this is an example of an exponential decayed function. So now if you compare to these two functions, we can make it more general. For a graphical feature of an exponential function, we will see this one, fx equals to a times b to the x. This is our exponential function. A is a vertical intercept of the graph. Because when x equals to 0, f of 0 is equal to a times b to the 0, which is a times b to the 1, which is a. So that means a is going to be our vertical intercept. Secondly, b determines the weight, which is increases or decreases. So if b is greater than 1, the function is going to be increased as x increase. And if b is in between 1 to 0, the function decreases as x increases. So that means the function for b greater than 1, the function looks like this one. But if b is in between 1 to 0, the function is decreases. Also, you notice that the function has a horizontal intercept. Which is the x-axis, y equals to 0. And then we know that the function is going to be concave up. And for the domain of the function is what? Negative infinity to infinity. That means all the real numbers. But the range of the function is always greater than 0 and go up. That means the function is always positive. So how do we graph the function? So we have been using we have learned some transformation of a function. For example, if I given you a function fx equals to -3 1/2 to the x plus 4, you need to know, hey, what is the basic function and what transformation has this been to? So to identify the basic function, so the basic function is going to be fx equals to 1/2 to the x. So that means originally the function is going to look like this one, and passing the point 0 and 1. I should also say that of the function is going to passing the point 0 and 1 for the basic one, fx equals to b to the x, because when x equals to 0, fx equals to 1, no matter what b is. Okay, so now let's get back to here. So this is the basic function. And then if you times -3, so that means the function is going to be vertically reflected and stretch. by 3. So the function is going to look like this one. So here is going to be 0 and negative 3. And then after that, the function it will be fx look like negative 3 times 1/2 to the x. And then you add 4. After you add 4, the function is going to be vertically shift up 4 units. So from the previous function, which is negative 3, 1/2 to the x plus 4. So that means our function is going to look like this one. And then we'll pass the point 1, 0. Okay, we use this function technique, the transformation technique, to draw the function. What if the opposite way, that I given you a graph and I want you to find the function? For example, if I given you this function, how would you find the original function? So in here, you may notice that, hey, the horizontal asymptote is equals to -1. So that means the function from fx equals to ax to the a times b to the x is going to be shift down. So the function, at least we can start in with this one. And now let's look at the points. We found some points that the function is going to pass in by. Well, we know that the function is going to pass in by the point. It passing through the point 0, 2, I'm sorry, 0, 2. So let's substitute the function 0, 2. I will have f of 0 equals to a times b to the 0 minus 1 equals to 2. And then I will have a times b to the 1, b to the 0, but b to the 0 power is 1. Minus 1 is equal to 2, so that means a going to equal to 3. We find our a, so our function is going to look like 3 times b to the x minus 1. Now we still need to find b. How do we find b? Well, we can find another point to substitute it, such as we can find the point we saw the point. Which one is more defined? 1, 5. So we can substitute. This is also passing through 1, 5. So that means we can substitute 1, 5 to the function. I will have 5 equals to 3 times b to the 1 minus 1. And then when we solve it, I have b equals to 2. So that means our function for this graph is going to be fx equals to 3 times 2 to the x minus 1. Remember, put the parentheses next to the 2, otherwise your function may look like, hey, 3 2 to the x minus 1. It's more like, look like 13 2 to the x power instead of 2. Okay, that's it for today's class. Let me know if you have other questions about graphing an exponential function.